All right. And I'm going to assume you can all see that.
Yes, it looks good.
All right. Okay. I'm going to talk about the more interesting, a few of the interesting observations during the past year since the last annual meeting we had. Since the last annual meeting we had, which was, I think, late July, early August of 2023, we received 1,240 events in that time. So there was no problem at all finding something to talk about today. Um, there was a problem finding, picking out which ones we had time for and which we just don't. Um, by comparison, the prior meeting, we had 495 events to choose from. So meeting to meeting, we've gone from 495 to 1,200. And I think Dave Harold is going to be talking a little bit about the big increase in events that are turned in. But we'll get going here. Um, what we're going to do is step through a couple of the big events, meaning large asteroids, large number of observers, a couple of the small but very important events, and then something from the category of asteroids and the satellites, something from the category of double star events, and then this presentation actually has a short appendix. The last 5 or 10 minutes, I wanted to run through the review process, especially for the newer people, so they understand what's happening when they send in their events to IOTA. And to start out, I'd like to apologize if I mispronounce your name or the name of your favorite asteroid or any of those things. Being such an international type of thing, the asteroids have some fascinating names, um, none of which can pass spell checker, and none of them which many I've never figured out how to pronounce. But so please bear with me on pronouncing all of this. Um, the first one is one of the large events for North America. It wasn't the largest by any stretch, but um, back uh, in 2023, late 2023, Inter Omnia number 704. Its diameter is 306 kilometers, not gigantic, but big enough, nice path across the continent. And we were able to put together quite a few observers for this one. The sort of northeastern group shown here, up near the Great Lakes. John Moore from Oklahoma managed to get in three sites. A good scattering of all of these are probably familiar names to you. Steve Mesner and Art Olson and so on, and Vadim Nikitin. Um, in the southwestern part of the continent, in Arizona and Southern California. The Dunhams were on it. Roger Venable from Florida or Georgia. I don't remember now where he lives, but he came all the way out for it. Bob Jones, again, a lot of familiar names. Had a big group. These are all people that were successful in getting observations. And then there are others that were clouded out or for some other reason didn't get good data. That this was the result of it. Um, and you can see that um, given the scale of things, it fits the shape model quite nicely. We had 21 observers that got good data on this one. Uh, Unfortunately, only one miss. As we'll talk about a little bit later, it's really nice to get things on the edge and just be on the edge to put good constraints on it. But this one was well defined enough that Very, very good result from across most of the continent. Turned out very, very well. The other big event that I wanted to talk about is actually Titania, one of the moons of Uranus, and that's this one is significantly larger. 1,577 kilometers is what Occult puts on it. And you can see it covers most of the United States and southern Canada. And a nice long event, of course, it's almost 73 seconds. And once again, we were lucky enough to get very good coverage, a very good northeastern group up here with George Viscomi and Kai Getros, Kevin Green, Steve Connard, and then clear out here all the way almost on the coast there. We have an observer there. I think he was using a remote site. And then on the western part of the continent, we had quite a few people in especially California, Arizona, up into Canada, Graham Schmidt up there. These sites are just all colored yellow. This is where they were relative to the green center line, and the blue, of course, is the path limits and 1 sigma. Now, the result came out extremely nicely. And in this case, as I mentioned, we managed to get events right on the very edge up on the north here with Peter Cervolo, and on the south with Don Brun, I think it's Don Bruns near San Diego, very, very close to his track. We had several constraining misses from Paul Malley, Tony George, the Dunhams. So these kind of things are especially useful. And I know Mark Buey at SWRI is a strong advocate of not necessarily planning on being on the center line all the time. It's very useful data to be out on the edge and either getting a small event there on the edge or a constraining miss. So very, very valuable set of data. And you'll notice here that the predicted line is quite a bit, a little north of where the center of the circular ellipse is. It's actually about over 220 kilometers north. So we're able to help out these predictions. It'll do a better job next time. When we plot the results, all of the green dots show the sites with positive. The red, of course, is negative. This is the way it was expected. But we do have Graham Schmidt up here who got a miss, even though he's well within the path limits. And down here, Don Bruns got a positive response, even though he's almost out at the 1 sigma line. So really what we've determined is that the whole orbit path is further south by right around 200 kilometers. So very, very good result and excellent coordination. Things wouldn't line up nearly as well if people weren't all getting their timing right and their positions right and all doing exactly what it is we need. So we see a big correction of the path from that where the predicted to this where it actually was. And sort of the bullet point or the advice from these large events is to live life on the edge. Like I say, Mark Buey is a strong advocate of this. And I've started changing some of my observing plans based on that. If I have a choice between an observation of being a single chord on an asteroid versus being the second chord on an asteroid, but out on the edge. I'm always going for the edge now. Um, we get quite a bit more useful information when we get that second chord across an asteroid. On the small events, Dave Harold will be talking about these in his talk tomorrow, but he and Dave Galt did send me some preliminary results, and so going from the 1,500 kilometer event for Titania, we dropped down now to an 800-meter Didymos, two Didymos events. Those paths were across the central US here, and then on the 19th, there was also a fair Didymos opportunity across California and part of Nevada and Idaho. But very low in the sky, 11 degrees, I think, for these Californian observers that did get it. That was a really tough one. But this one we were able to get good data on it as well. These are the stations for the 22nd observation event for Didymos. These are the people that got data. Also on the campaign, Roger Venable, who actually had 4 telescopes, an 11-inch and 3 14-inch scopes that he brought out from the east all the way to New Mexico, but he was weathered out. And then the Dunhams were also involved. I believe they had equipment problems, but we did get 4 sites with good data. Mike Skrutsky up here in the northeast, Kai Getros, Steve Preston, and myself. One thing you'll notice, and one thing that the bullet point that's coming from this type of observation with an asteroid this small is to be very aware about elevation corrections. You'll note that when we plot out of Occulta the path here and the sites that each of the people used, they're all out of the path. For example, this is Kai Getros' actual site, his GPS. The path itself plots up here, but that, of course, is because of the elevation correction that has to be done, particularly on the smaller asteroids and in the higher elevations. To do this, we're using Occult Watcher Cloud, the mapping on Occult Watcher Cloud. And if you're using Occult Watcher Cloud to pick your locations, it will show the path as predicted. In this case, I've just put a marker here for Kai Getros's position. So what he did was select his site here. It draws a line up to where that elevation correction is actually getting data. And it's dead center on top of the green line, which is now covered up by the white line that Occult Watcher drew. But he is that obviously at first glance, he's outside of the completely outside of the path. So his planning and all of our planning had to include elevation corrections. So we're all located in this particular case, south and west of southeast of the actual path, and absolutely critical. If we had just all plopped our stations down in between the two blue limits, every one of us would have had a miss. The results of it, this is the September 22nd event, fit very nicely with a shape model for Didymos. The size right about 800 meters wide. My chord, the miss up here, Kai Getros just barely on the edge, and then both Mike Skrutsky and Steve Preston got good, strong positives. right through there. And what it looks like, that the center line for this particular event was right along Kai's line here. So the predicted center line is here, and we basically are showing that Didymos is about half of a path width south of that predicted line. And like I said, Dave Harold's going to discuss the importance and the results of the Didymos data sets in his talk. The other one, the September 19th Didymos event was over here. We had 3 observers on that. In these cases, all of these observers were at very low elevation, just a few hundreds of meters at the most above sea level. So elevation corrections weren't as important to them. Yanji Liu and Rick Liu were stationed here, aimed at the center line out in the farm fields there in Central California. Richard Nalthenius and Kurt Bender were over much closer to the coast, the western coast of California. They both got negatives. They both had misses. And Yanji Liu and Rick Liu got what we would call a tentative positive. This is the plot that Dave Galt and Dave Harold provided. And the Liu chord here runs, they've got an event, but although they've also got some big error bars. And it looks like the Liu chord went through certainly the diffraction pattern of the asteroid. Definite misses on Kurt Bender and Richard Nalthenius. So the Daves in Australia explain that this will go in as a positive, although it's not certain enough for astrometric use. That's the and just an example, since we talked about it on the prior Didymos, this is the elevation correction for this September 19th Didymos path. If one of those observers had decided to go up into the Sierra foothills, where elevation is close to 2,000 meters, if they had plopped their sight down on the center line, on the green center line, what it means is that their actual elevation correction point is well off of the path, and shifted quite a bit in time as well. So again, just trying to make a bullet point out of being sure that you're paying attention to elevation corrections, particularly when you're at high elevations in the mountains and or when you're dealing with a very small asteroid, in this case only 800 meters. So that's your second bullet point from all of this. So we've worked through the big events, small but important events. Didymos is extremely important because since that was the target, its moon Dimorphos was the impact point for the DART mission by NASA and ESA, I think. So keeping close tabs on that orbit is absolutely critical. And as we've mentioned many times, the precision that we can get out of occultations is far better than anything anybody can do with a telescope. The next topic is asteroids and satellites. Now this is an example of what at least in my mind, and I think the way other people think, this is typical satellite discovery. This one happens to be Arecibo back in 2021 by Dave Galt and Peter Noseworthy. And we see just these classic textbook type of double events where we have a good event for a main body, and then afterwards a smaller but very well defined event. And Peter Noseworthy's the same. Very good event for the main body. Afterwards, a small amount. And that's what most people think of as a typical satellite discovery. But there are other types that occur. This one's another example of the typical one. We discussed this in the last meeting. Adelheid, Kevin Green and Paul Malley, again, main body, good event, and then somewhat afterwards, nice, well-defined secondary event. That's typical. This is what it looks like in the sky plane. This is Arecibo. Noseworthy and Galt both see the event on the main body, then they both just barely caught the secondary body. In the case of Adelaide, both Paul and Kevin caught the main body, and then only Kevin got the satellite out here. Now, a different way to find satellites is what happened with 5232 Jordanes earlier this year. In this case, Graham Schmidt, Mark Simpson, and Bill Young in Canada are spread sort of across the path of Jordanes. Graham and Mark are well inside the path. Bill Young was just barely on the edge. But what they found was large event for what we'll call the primary body. And then Graham and Mark saw a smaller event. They did not see the large event. They did see the small one. Bill Young saw the large one, but not the small one. So in this case, instead of two events on any single chord, we've got three chords that are necessary to define the two events. Roughly, this is what Jourdain was finalized as. I think in the most recent plot I saw, this part of Graham's chord had some error bars on it and some overlap, but this is the way it originally came in. Regardless, this one was followed up and was confirmed using asteroid light curves, prior asteroid light curves, to develop basically and conclude that it's consistent with a synchronous binary system. So the confirmation came from other data rather than from another occultation. In the case of Arecibo, for Peter Noseworthy and Dave Galt, the confirmation of that discovery of the secondary body came, I think, within a month or 6 weeks by more occultations in the US. Kurt Bender and Richard Nolthenius got the same results on an Arecibo event and confirmed that secondary body. So two different ways to confirm here. And just a very quick note, I literally got this plot this morning from Dave Galt. There was an Arecibo event that just 2 weeks ago. In that case, let's call it the silhouette of the two bodies overlap, meaning that the smaller body is towards us or away from us, one or the other. But it appears that this also confirms the discovery of this secondary body on Arecibo. So that's very encouraging. That's now at least 3 sets of observations on that asteroid and its satellite. Um, let's see. Those are the recent Arecibo results. And let's see, we don't want to run out of time, so go to anyway, the bullet point from the asteroids and satellites part of the talk. The bullet point is multiple stations on an event is often greater than having multiple single station events. This is something that Bill Young has talked about several times. I'm also an advocate. I will always lean towards getting additional data with somebody else's cord on an event rather than going off to get another single station event. The the information we get from multiple stations on an event is far more than the sum of individual ones. And there's a transition slide missing there. Oh, the last topic is curves, light curves. The whole goal here is to get people to pay more attention to their light curves and to track down Dave Galt's informational video on how to generate your own Vizier curves and then send them in. This is an example, one of my events with Dave Osper. By looking carefully at the curves and paying attention, you can see this is obviously a 2-stepped event and very, very similar to Dave's down at the bottom here. If Dave or I can ever get this written up properly and submitted to the WDS, then it will be a double star discovery. But one thing that we're trying to get is to as many people as possible to send in their Vizier curves so that everybody has these available. I think a large number of double star discoveries have slipped through the cracks because we aren't paying enough attention to the curves. So our bullet points for the entire talk: live life on the edge, get out there on the edge of the asteroid, on the edge of the shadow. That helps put constraining data out there. Pay attention to those little white lines when you're using Occult Watcher Cloud. Those are elevation corrections, and you may be picking a spot that's actually not going to see an event because you're outside the path due to elevation effects. Multiple stations on an event are greater than multiple single station events. Go for helping out on somebody else's event if you have a choice. And then slow down your process for the curves. Actually pay attention to them. And when you're filling in your report form, be sure you add comments that say possible step in the light curve or possible central peak in the light curve. That way, fewer of those events slip through the cracks. The appendix is just a very quick rundown on the review process. Like I say, especially for